Hi, this recording is for Algebra 1, Chapter 5, Lesson 4. No quote today because I want to keep going because this is brand spanking new. This is using concepts you guys are familiar with like slope and point and giving you a whole new formula that some of you guys have not seen before. This goes along with standard form in that it's new, so I want to make sure I spend as much time on this as I need without wasting your time with the quote. So explaining all that was basically the amount of time it took to read you a quote. All right, so point-slope form of an equation of a non-vertical line that passes through the point xy and has a slope of m. So you guys are all familiar with slope. That's this one down here. Y2 minus y1 over x2 minus x1 equals slope. It's the difference in the y's over the difference in the x's. Difference means subtraction, so subtraction is really important. And above it, we have the point-slope form, which I am boxing in red as I speak. Okay, so the point-slope form is based off of the slope formula, y2 minus y1 equals over x2 equal minus y2 minus y1 over x2 minus x1 slope. So let's start with that formula, and because it's based off the slope formula, and we're going to replace x1 and y1 with some numbers. Let's say we replace it with 3, 4, and we have a slope of 2. So if we plug this information in, we know that, and because I'm replacing y1 and x1, y1 was 4, x1 was 3, and we know that the slope is 2. So basically, I've just plugged in information that I may or may not already know about a line into the slope formula. And then I'm just going to kind of simplify the formula. So I kind of want to get rid of the fraction bar. Let's just say I want to. So what I'm going to do is I'm going to multiply by x2 minus 3 on both sides. The x2 minus 3 is going to cancel out on the left. And I'm going to be left with the formula y2 minus 4 is equal to 2, which is the slope, times x2 minus 3, where the actual point that I know, excuse me, it's a little early, the actual point that I know from the equation is the 4, which is the y-coordinate, and the 3, which is the x-coordinate. Now it's very important. Because slope formula uses the difference, we're not adding here, we're subtracting, that kind of can throw a little monkey into your wrench about how things are written and how to extract information. So there's an important thing here, which you can just barely see. Oh, there it is. I'm sure you can see it fine. Notice that the point coordinates are positive in this case. So these guys right here are positive, right? But by adding the opposite, they become negative in the equation. So if I were to add the opposite, basically here and here, they would become negative. So pay attention to this when we're extracting information such as point coordinates from something that's already written in point slope form, because that, it gets a little weird. All right. So let's say we need to graph. So again, this is my little note, just to remember that if it's negative, the number is actually positive. So that's actually, yeah. So yeah, if there's a plus sign, then the coordinate itself is negative. Let me rephrase that. So if you end up seeing a plus sign here, in here, or here, either one of them, then the actual coordinate itself is negative. But we'll talk about that more in just a second. Okay, so here's the equation. We have y minus 5 is equal to negative 2/3 times x plus 2. And I'm going to go through and add the opposite. So instead of having a plus sign, I'm really going to have a minus and negative. So that's what I'm talking about right there. Okay, I went from here to there. All right, so basically that means that this point, use a different color, this point is actually negative. So since this point right here represents the x-coordinate, I'm really going to end up with, well, I'm going to first end up with the slope of that because that's the slope. Slope is one of the easiest things to determine here. So slope is negative 2/3. But if I'm going to go find the point, the x and the y, the x is negative 2. It is not positive 2 like you would think just from looking at this equation. It is actually negative 2. And the point here is positive 5, even though you'd be like, but I added the opposite, Miss DH, and it's a negative 5. No! The reason it is not negative 5 is because this formula is based off of the slope formula, and you got to pay attention to that because it can really trip you up. All right, so I'm going to graph the point. And then I'm going to use the slope to find the next point, and the next point after that, connect the dots, and guess what? Bada bing, bada boom, you got yourself a straight line. Okay? So that's how you determine the slope and the points for point-slope form, which allows you to graph this line very easily without having to make a table. The whole reason we like to do this is so that you can graph without having to make a table, because tables do take time. And if you need to identify or if you either have to identify or make an actual graph, and you're in a time crunch, it kind of helps to be able to do this quickly. So that's one of the reasons that we have you guys graph all these different ways, is so that you can get them into a format you're familiar with, so that you can graph quickly without, again, having to do all of the math involved with figuring out individual points on a line and then connecting the dots that way. Okay. Next slide. Here we're talking about writing an equation based on only 2 points. The equation we still want to be in point-slope form. So the first thing we're going to do is we're going to figure out the slope for these 2 points between 2, 3 and negative 1, negative 5. So I've got the slope formula. I've plugged in my x's and my y's. I'm going to add the opposite, and I'm going to add. I'm going to get 8 over 3 because 3 plus 5 is 8 and 2 plus 1 is 3. So that's the slope. And now I'm going to just pick a point, and I think I picked 2, 3. I did. So I'm going to plug in 3 for y1 right there, and I'm going to plug in 2 for x1 right there. All right. Now, as you guys can see in the formula down here at the bottom, I don't use the subnotation. I don't say y2 and x2, so you really don't ever need them in your answer. So that would be probably your final answer right there. There you go. Okay. All right. So now let's go ahead and put this point-slope form into slope-intercept form. So how are we going to do that? Well, we're going to distribute the 8 over 3, the slope, and we're going to get y minus 3 is equal to 8 over 3x minus 8 over 3 times 2. Simplify that. Simplify it. And you're going to end up with 16 over 3, though I didn't get the 3 in there. It's there. You'll see it. Bang. There it is. So then I'm going to add 3 on both sides to get y by itself, because if you remember, slope-intercept form is in the format y equals mx plus b. And so as you see, my slope stayed exactly the same when I converted this to slope-intercept form. All right? So when I added 3 on both sides, I'm going to end up with negative 7 over 3. And then again, this is your y-intercept. That's where the line hits your y-intercept. So there's a lot of information you can get just based on the point-slope form. You can get a point on the line, you can get the slope of the line, and if you convert point-slope form to slope-intercept form, you can figure out what the y-intercept is reliably without having to graph it and just visually take a look. Because again, obviously, when you've got something kind of like this, it's not an integer. It's, it's a 2 1/3. Yeah, 2 1/3. So, graphing that is going to be a little shady, especially if you're doing it on graph paper. If you've got a graphing calculator, the graphing calculator can actually tell you. If you've got computer software, the computer software can tell you. But you can avoid all of that just by doing a little bit of math, and it'll tell you exactly what the point is without having to graph. All right, second to last slide. And the last slide is really short, so I'll be done soon. All right, so to determine if data represents a linear relationship, check the rate of change. If the rate of change is consistent for consecutive pairs, it's supposed to be pairs of data, when it represents a linear relationship and the rate of change is the slope. So here I went through and I looked at the differences. The differences in the x's is that negative 11 to negative 1 is a 10 increase. An increase from negative 1 to 4 is a positive 5 increase, and 4 to 19 is a positive 15 increase. Whereas for the y's, we have a 4 increase from negative 7 to negative 3, a positive 2 increase from negative 3 to negative 1, and a positive 6 increase from negative 1 to 5. So if I turn these into fractions where the differences of the y's are the numerator and the differences in the x's are the denominators, I'm going to end up with some pretty consistent fractions here. So 4 over 10 is equivalent to 2 over 5, which is equivalent to 6 over 15. So that means that the data is consistent for the consecutive data, pairs of data. You guys see how that worked out? So this is what we will say, yes, it is a linear relationship. So now we need to figure out what the slope-intercept form is. Or, excuse me, not slope-intercept. We're doing point-slope today. So the slope is consistent. We're going to use the slope, and I'm going to use the most simplified slope. And then I'm going to just pick a point. So I picked the point negative 11, negative 7, and you plug it in, and then I went ahead and added the opposite. All right, so see, even though that the negative 7 was the x coordinate and the negative 11 was the y, negative 7 was the y coordinate and negative 11 was the x coordinate, when you do add the opposite, your equation does change a little. Okay, so this is just a recap of what we've talked about over the last 3 lessons. Slope-intercept form, which is just a refresher from pre-algebra. Standard form was our last video, and we just talked about point-slope form. So make sure you guys know the ins and outs of these. You can go between them. Most of them only simplify down to slope-intercept form. Standard form and point-slope form have trouble with each other. All right, that's it. I'm done. Bye.